Welcome to AI Frontiers, your guide to the latest developments in artificial intelligence and computer vision research. Today's episode is titled Computer Vision's New Horizons, Synthesizing 140 Papers Published on May 26, 2025. In this deep dive, we explore the newest breakthroughs in computer vision, drawing insights from 140 research papers published on the arXiv preprint server on a single day. The journey ahead will cover emerging trends, innovative methodologies, and the evolving future directions that are reshaping the field. Whether you are an industry expert, a student, or simply curious about how machines interpret the visual world, this episode will serve as a comprehensive guide to computer vision's current landscape and its trajectory. This presentation begins by mapping the landscape of contemporary computer vision research. The aim is to unpack the essence of the field by highlighting dominant themes and emergent trends, while also spotlighting impactful papers and key innovations. Methodologies underpinning major advances will be synthesized, providing a cohesive outlook on where the field is headed. Through this structured overview, listeners will be guided through the evolving frontier of artificial intelligence and computer vision, gaining a clear sense of how foundational research is translating into real-world impact. Computer vision is a specialized discipline within computer science focused on enabling machines to interpret, understand, and act upon visual data. Its capabilities extend from facial recognition and advanced driver assistance systems to medical imaging and industrial inspection, powering a wide range of applications that convert raw pixels into actionable insights for AI-driven systems. By integrating expertise from artificial intelligence, optics, and neuroscience, computer vision transforms industries and daily life, making it possible for machines to perceive and interact with the world in increasingly sophisticated ways. The first major research theme is multimodal vision language modeling, where the goal is to merge visual and textual information for richer and more contextual AI understanding. Significant work, such as Perspective, examines whether multimodal large language models truly grasp geometric perspective reasoning, a critical step for spatial understanding. Round R1 investigates methods to enhance interpretability by grounding model reasoning in specific regions of visual evidence, thus making AI decision processes more transparent. These approaches empower tasks like visual question answering, detailed scene description, and guided image editing, illustrating how multimodal models are bridging the gap between textual and visual reasoning. A second central theme in the current research landscape is three-dimensional scene understanding and reconstruction. The field is rapidly expanding from two-dimensional image analysis to comprehensive modeling of three-dimensional environments. Notable contributions, such as CCL-LGS, highlight the integration of language with 3D geometry to achieve deeper semantic understanding. Advances in neural radiance fields and Gaussian splatting are enabling high-fidelity 3D reconstructions from conventional images or video. These breakthroughs are critical for robotics, augmented reality, and digital content creation, as they allow machines to perceive and interpret the structure and spatial layout of real-world scenes. The third theme focuses on the rise of controllable and personalized generation in computer vision. Research efforts are increasingly directed at providing fine-grained user control over generated images and videos, encompassing attributes such as motion, appearance, style, and environmental conditions. The Total Editing Framework, for example, unifies the editing of appearance, motion, and lighting in digital avatars, while Weather Edit enables simulation and editing of weather conditions in three-dimensional scenes. These innovations empower user-driven creative design and avatar customization, making personalization and interactivity central advancements in the field. Ensuring fairness, robustness, and rigorous evaluation in computer vision models is a crucial concern as these systems are deployed in more real-world, high-stakes contexts. The development of feature-level bias evaluation frameworks, such as those targeting facial expression recognition, provides essential tools for auditing demographic bias even when explicit labels are unavailable. New datasets like ImageEdit support comprehensive benchmarking and model evaluation. Methods for mitigating demographic and data bias are gaining prominence as trustworthiness and transparency become central to the impact and acceptance of AI-powered vision systems. Key findings from this collection of research papers are redefining the frontiers of computer vision. The integration of causal reasoning, as demonstrated in studies such as Causality and In the Wild Re-ID, enhances model robustness by moving beyond superficial correlations. The application of reinforcement learning in works like Ground R1 and Omni R1 shows that models can be trained for evidence-based interpretable visual reasoning. Large, curated datasets such as ImageEdit are driving open innovation and setting new standards for model comparison. Agent-based approaches, illustrated by CPath Agent, are enabling explainability, especially in healthcare domains. The collective push toward transparency and interpretability is accelerating across the field. Several prominent methodologies are driving progress in computer vision research. Diffusion models have become foundational for generative and editing tasks, producing content by iteratively denoising random noise. Transformer architectures excel at modeling long-range dependencies in images and sequences, supporting both visual recognition and generation. Reinforcement learning is being leveraged to optimize model attention, resource allocation, and evidence selection in complex reasoning tasks. Contrastive learning, paired with hard negative mining, sharpens multimodal representation alignment, enhancing model discrimination. Data augmentation and semi-supervised learning strategies remain vital for addressing data scarcity, particularly in specialized or privacy-sensitive domains. The seminal paper, Total Editing, by Yizhou Zhao and colleagues, represents a breakthrough in controllable image synthesis. This work unifies the manipulation of appearance, motion, and lighting within a single framework for digital head avatars. The use of neural radiance field decoders enables intrinsic decomposition, disentangling these factors and granting users precise control over photorealistic avatar animation. By integrating lighting information from both portrait images and high dynamic range environment maps, the model achieves highly realistic relighting. The approach sets a new standard for digital avatars in media and virtual reality, demonstrating the field's progress in unified controllable generation. The CPath Agent framework, developed by Yuxuan Sun and collaborators, advances explainable AI in high-stakes healthcare applications. This agent-based model is designed to mimic the diagnostic logic of expert pathologists in high-resolution pathology image analysis. By employing agent-based navigation and zoom strategies, CPath Agent provides interpretable diagnostic workflows that outperform traditional black box models on new evaluation benchmarks. Its ability to enhance trust and transparency is essential for clinical adoption, marking a significant step forward in the development of trustworthy and interpretable AI systems for medical imaging and beyond. ImageEdit, introduced by Yang Ye and colleagues, addresses a long-standing bottleneck in image editing research by providing a large, unified dataset specifically designed for training and evaluating image editing models. The dataset covers a diverse array of single-turn and multi-turn editing tasks, enabling comprehensive benchmarking. The ImageEdit E1 model, trained on this dataset, demonstrates excellence in adhering to editing instructions and preserving image details. ImageEdit democratizes access to high-quality image editing capabilities, fostering open research and enabling rigorous, fair model comparisons. This advancement is pivotal for the community, bridging the gap between open source and proprietary solutions. Looking ahead, several future corrections and challenges are poised to shape the next era of computer vision research. Integrating causal reasoning will be essential for achieving robust generalization across diverse and unpredictable environments. The development of agent-based, interactive, and autonomous systems will blur the boundaries between perception, reasoning, and action, paving the way for embodied artificial intelligence. Personalized and privacy-preserving models will become increasingly important as AI systems integrate more deeply into daily life and professional domains. Ongoing efforts to address computational efficiency, dataset bias, and fairness will be critical for scaling and ensuring equitable impact. Transparent decision-making remains a central goal as the field evolves. The synthesis and review process for this episode was powered by a combination of advanced AI tools and human expertise. Summarization and narrative construction utilize the capabilities of GPT 4.1, ensuring a coherent and comprehensive overview of the latest research. TTS synthesis support was provided by OpenAI, with visual assets contributed by Grok. All content underwent expert human review to ensure accuracy and clarity. Full references to all cited papers are made available for transparency. Despite rigorous quality control, some minor oversights may remain, reflecting the rapidly evolving nature of the field. Thank you for joining AI Frontiers today. If you enjoyed this deep dive into computer vision, consider subscribing to our YouTube channel for more research insights and updates. Stay tuned for future episodes covering the latest breakthroughs in artificial intelligence. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.